Hello everyone, welcome to episode 10. So in this video we're going to learn big O of array list. So I'm going to use array list instead of arrays here.
All this concept, I need a data structure that's going to be dynamic and allow us to add new items and not just be fixed length, and lot of concepts that I'm going to show here will apply to arrays as well. Also, instead of showing our array list like this, I'm going to represent it like this so I can show the indexes. Now we'll just walk through some of the methods for array list and what the big O of those methods are. So now we'll start out with my array list of my array list. So say dot add the number 17, that's going to do this. And when we add something to this end of the array list, so it's pretty simple process because we don't have need to be changed. Likewise, when we remove this item with a dot, remove at the index of 4, and we remove that, there is nothing that needs to be re-indexed on the array list. So it is one operation to add something, it is one operation to remove something. So this is O of 1. This is different. If we do something on the other end of the array list, so we say my list dot remove the item at the index of 0. This one right here, when we remove this problem that we have, is no longer at the correct index. So we need to change the index of 1 here to be an index of 0, and then we need to do this all the way down, touch every item in the array list. So if we add an item at the index of 0, we bring that 11 back, we need to change this index, and then we have to do all this way down to make the room for that 11 to be index of 0. So in this case, n is the number of items in the array list, and because we had to touch each item, that means this is O of n. And because we have to touch each item, that means O of n, so it's O of 1 on this end when we are adding something or removing something, but it's O of n to do those things in the end. So when we remove that item, we have to be re-index every here. If we bring it back, we have to do all the re-indexing again to bring it back. So it's one of and it's O of n on the other end. So if we say my list dot add at index 1 the number 99, that's going to be indexed here, we are going to drop the number 99 here. We do here re-index that item, that make that at 2, and this is a 3 and that 4, and we have to touch all the items that come after where the insert happened. So that's O of n. So you might say that there should be O of half n, because on average the insert is going to be somewhere in the middle and you will have to touch half of the items. However, there is a problem with the logic. First, O of measure worst case, not average case. But even if O of half of n was our worst case and half is a constant, we drop constant. Like otherwise, when we go to remove that item, we are going to have the re-indexing every time, and so now it look something by value. Let's say we are looking for the value of 7. We start the beginning of the array list or the array, and we say this is the value of 7, this is 11. We are going to move until we get the value of 7. So we are looking the item by value is O of n, but it's different. We are looking by index. If you're looking for the index of 3, we don't have to iterate all the ways through this. We can directly to this index, and that is O of 1, and that is
Big O of array list.